Someone VMD is not working, this column. It is not getting installed.
See, let us repeat, once again how to, make the force field file. Right now, see, if you want to run towhee, we need two things. Right? In last class we have discussed. So the first thing is the input file, towhee underscore input. And second is towhee underscore force field. Force field underscore some variable. So if you want to do any simulation, first you have to find the force field parameter. Right now, so in this case, we are using OPLS force field. OPLS for ethanol, OPLS all atom. Similarly, there are several other force fields. So first you have to identify in your problem what type of force field you want to use. Clear? So in the case of OPLS, we have a wave server leak parallel. So from there you can download the force field parameter. If anyone has any doubts in leak parallel, how to generate the force field in leak parallel. So make a PDF file, upload it, you will get a force field file. So this is the force field file from the leak parallel. Right now. So we need how many parameters? So first one is the non-bonded. Non-bonded we have sigma epsilon. Then we need bond length parameters. In the bond length parameters, we have Kr, coefficients, and R naught. Right? Then we have angle. In angle, we have K theta and theta naught. Then we have, in the case of ethanol, we need torsional parameter. In the torsional parameters, we need V1, V2, and V3. Clear? So we need, first is the non-bonded parameter, sigma or epsilon. Right now. So for that, you have to identify the type of atoms. So you can do the identification of type of atoms from the charges. From the charges, right? So this is the atom number given by the Lig Pargen, and this column is basically the charges. So you have to give some variable name to each type of atom. So I have given for 800 carbon Ce, carbon of ethanol. Right now. Then the remaining three, 801, 802, and 803 is the hydrogen atom of CS3. And all of the hydrogen have the same charges. So all the three hydrogens are of the same type. So I have given the variable He. Then we have the second carbon atom of different type. So I have given the variable Ce1. Charge is this one. Then these two hydrogen atoms are different from the CS3. But both are same. So I have given the variable He1. Then we have oxygen. Then we have again hydrogen atom. So in a similar fashion, for each molecule, you have to give a atom type name. Right now. So once you have done this, then you come back here. So put a variable name against each number. Right now. And for this atom, this is the epsilon kilocalorie per mole and sigma in angstrom. Convert this kilocalorie per mole into Kelvin. Excel sheet and convert it. So any question in sigma epsilon. So in the first force field file, first you have to fill the values of sigma and epsilon. Right now. So just check your force field file. So here is our force field file. So first is the version 15. Type of non-bonded is 6. Right, 6 atoms, 6 different types of atoms we have. Then the next is Lennard-Jones potential. You write LB or geometric, whatever you want to use. Then for first atom, sigma is 3.5, epsilon is 33.21. Right now, and the rest is 0. Mass is first is carbon, so mass is 12. Element is carbon. Bond pattern, if you if you don't know, you write null. or you can use sp3 for carbon in cs3. Charge is 0. These two variables will be by default 0 and 1. Then you write the name of the force field. So I'm writing the variable OPLS ETH. OPLS force field for ETH for the ethanol. So I'm giving this name. Then you have the atom type CE, 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 CE. So just repeat all these values. So everyone has done this for first atoms. Huh? So just type these values. So these are by default 15, 6, you put 6 number. These are again default. Then you start with 1 sigma epsilon 0 0. This is carbon. So 12 carbon sp3 0 1. Name of the force field is OPLS ETH, and the carbon type is atom type is CECEC. Similarly, for the second is hydrogen. So 2.5, 15.0, 10, and 00. This is hydrogen. So mass is 1, element is hydrogen, bond pattern is S, phase charge 0, this one OPLS, and atom type is HE. Fine. So you have to repeat this, this format 6 times for each atom type. So you just cross check your values. So this is the third 3.5, 33.21, 00, 12 carbon sp3 01, force field type is CE1, 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 CE. So repeat till this point. 6. Yes, at this point.
I will consider the hydrogen atom as atom number 3.
No problem.
Okay.
Order is not important here. No? You have to only define all the different types of atoms. Order is not important. Order is not important. You can define anywhere. Non-bonded. 20. Correct. That yes, see. The first time when you put sigma, second is equal to hydrogen, second one is 2s. First last. So everyone has done the non-bonded part, right? Everyone has done or I have to wait?
Okay. One bounded and one data and write it down. The total. Okay, next you. Non-bonded. Plus the other bonded. এটা আমি clarification না আসা so আমি bonded atoms are selected consider here so that's the general only. But both define you handle the different points is only defines define atom or right one thing.
Hey, please cross check your values once again for the non-bonded types. Hey, in the bond parameters, bond is between, let's say, 801 and 800. So you replace all the 800 by your own variables, whatever you have defined. So in my case, 800 is CE. So replace all the numbers by the variables. Clear? Then only you can identify the different types of bonds. So in this case, this is between HE and CE. So all are same. So in the force field file, you have to define only once between HE and CE, right? Because all the parameters are same, 340 and 1.090. So replace all the numbers by the variables. Then only you can identify different types of bonds, different types of angles. Total bonds are, total bonds are how many? So total we have 8 bonds, right now. But how many types? So types are only 5. So you have to enter only 5 types, not all bonds. Yes, that is the standard. Right.
understanding this thing.
What I'm saying is replace the numbers by the variables whatever you have defined. Replace the numbers by the variables. Right now, so in my case, see, I have defined all the atoms from 800 to 808 by these variables. Right, so throughout you replace the numbers by the variables. This is the first thing you do in Excel. Then only you can identify the type. Once you do it, now you can see here we have 3 bonds, but 3 are of the same type. Then only you can identify the types. Right now, similarly, these two are same. This HEC1, HEC1 are 2 types, but we have to write only once because both are of the same type. Any doubt? Sigma in industry. Yes, so you have already defined some types. Right. Now for each actor, you have the non-bonded coefficients. One of the sigma starting one. So this code defines 4 elements. Anything we need only 6 actions. So started to put in so this is sigma, this is epsilon. That is the mass. Bond factor sigma, right? Right. This is the name of the force to take. So this is for the one atom type. Now we need 6 times. That is done. Now go to the bond length. Yes, down. Yes. That, yes. Now it is the number of bonded. Right. So how many bonded atoms are there? Total 8. How many times? So 5. You have to write 5.
what is the number of bonded atoms? Five. Yes, yes. Not just. The bond type number is one. Then what is the bond style? Today I have discussed now. It depends on what is the form of the equation. I'm not first equation. In the software, they have defined different equation by a number. So one for length. That second means harmony. Here it to R minus R not start. We have to. If you are putting two, you need two coefficients. One is the R naught, another is the R. So first one is for the R naught. Yes. Then you have to enter the second value. You have to enter the second value. So what is the bond length for this? So this is your first bond line, na? So what is your first bond type? Let's say you say HECE. HEC is 1.09 is now. So you have to clear 1.09 is now. First line. 171 097. That's it. Additional units in don't do by itself. Then come back in the amount of the force pair. How many have the same sign? So then at the max you have it just to the same sign. So you have this way. Go to the way. So you can see for the angle. Okay. Maybe all at once. इसमें जाके देखिए टॉर्सल बनाना कंट्रोल करते हो अगेन देख करके इसमें जो आपको टोटल येलो है ब्लैक देखो टोटल बॉन्डेड तरफ से इतना और क्या है HEC एक टाइप हो गया एक हो गया दूसरा क्या है C1C तीन हो गया फिर उसके बाद H1C1 दो बार एक हो गया तीन लास्ट में फिर दोनों पांच मैक्सिमम बात कर लो उसके बाद ये बता आराम से बनाने का इवन से कोफिशिएंट्स में दो डालना पड़ेगा कौन सा R0 भी एंगल्स कम है और PR ये भी रिपीट कर दो
ये मतलब आप लोग
कौन सा एंगल
एलिमेंट बनाए
है